Now I'd like to welcome Paul Thompson, who's going to share with us the Passive Rowhouse Manual that he, with others within the Philadelphia Passive House community, developed in part to engage and inform their membership. I believe that there are useful parallels between Chi-Town here and Philly, and of course other cities throughout the world, really, in terms of both challenges and opportunities in transforming our existing building stock into the low carbon, healthy, comfortable buildings that we're all striving for within the passive building approach. So Paul, I'm going to turn it over to you and let you take over.
All right. Okay. So here to talk about the Passive Rowhouse Manual. Nice to see you all here on the small screen. Thanks, Jennifer and Tony, for the invitation. The Passive Rowhouse Manual is a guide to renovating row homes to passive house performance. And this is me. My name's Paul Thompson. Laura Blau is also on this call, and I form Blue Path Design, an architecture firm focusing on sustainable design and specifically passive house and Passive House certified and Passive House inspired projects. Today, however, I'm presenting as a member and former co-facilitator of the Green Building United Passive House community. We'll be looking at the Passive House Manual, which was developed by this volunteer organization. And I wrote a couple of chapters and led a couple of the charrettes that led to the manual. We'll talk a little bit more about what that means, probably in the slide here. I wanted to start with an approach to renovations. You probably all recognize Sam Rashkin, who developed the Energy Star program for the EPA. I've heard him speak a couple of times at Passive House conferences, and I wanted to share some of the simple takeaways that are the starting point for making decisions about renovating buildings, whether they're passive house or not. One, Energy Star performance is not good enough. And more importantly, on a limited budget, go for the permanent solution when you can. You don't want to build and then unbuild, because that's not a sustainable solution. The decisions that you make lock in building performance for a minimum of 25 to 75 years. Green Building United, our host group, or Passive House Communities host group, promotes the development of buildings that are sustainable, healthy for inhabitants, resilient, and cost-effective. It's a local Philadelphia organization that has been around. You may have heard it previously in a previous incarnation. It was Delaware Valley Green Building, Delaware Valley Green Building Association. Council, right? Thank you, Laura. If I forget things, I got my partner Laura here to remind me what to say. Through education, advocacy, and strategic initiatives, Green Building United informs and engages individuals and organizations and transforms the way buildings and communities are designed, built, and operated. Green Building United, by the way, it's a great organization. You may have also seen BBU that hosts a yearly sustainable symposium and also hosts the New Gravity conference, which has been around for 6 years and has focused on, I think we're working with you a couple of years ago for a virtual version of New Gravity conference. So the Passive Rowhouse Manual. So why row houses? It seems obvious for people who live in a row house community. But the Passive House community wanted to address Philly's ubiquitous housing type. Like all old cities, that haven't burned down at some point in their history, Philadelphia had lots of row houses, a common and inexpensive building type known for efficient use of space to house people. Party walls that share structure and smells, providing high awareness of what your neighbor's up to and what they're having for dinner. And these are some examples of Philadelphia row homes. And there are fancier row homes, and there's also a mini one called that we call a Trinity, or a Father, Son, and Holy Ghost. It's a 3-story, tiny little row home that is stacked with a winding stair and it was often found in the middle of blocks of other row homes. And from what I understand, back in the day, there was one family per floor. This is like a 12 by 12 footprint. But we're going to talk about applications that could happen to any size row home. Now, in the demonstration projects, which generally had 25 to 35 attendees with pizza and beer, we started with a brief lecture on a building science from a community expert, and then moved on to a hands-on event. We also visited construction sites, we installed windows, and generally it was a lot of fun, both for us to set it up and to participate. And you can see there's these number of 12 or 13 that correspond pretty closely to the chapters and the information that we'll be talking about that are in the Passive Rowhouse Manual. And here's some action photos. Obviously pre-COVID, we learned how to install windows, perform blower door tests, and find air leaks, design mechanical systems, learned about the moisture cycle and hydrothermal and energy modeling. All in all, it was a lot of fun mixed in with building science. And it's surprising how easily science can go down when you mix in fun and beer and have a good time with the people that you like. So you can see we're in some cases, we're in basements. Here in Timberlake, Architects here in Philadelphia was a major sponsor during this time. And we spent many of our demonstration projects in their offices, and they were just a big help. So the Passive Rowhouse Manual team takes a lot of work. Again, this is all volunteer work. So, once again, a public thank you to all the editors, authors, designers, and the support staff that made this manual into a reality. It was about a 2-year process to actually get the written part done and turn it into something that we could present out to the public. And of course, our financial backing and other heroes that have made it possible make the manual possible, and also support us as we work in the nonprofit realm. Special thanks to the SEF, Sustainable Energy Fund. They made the manual possible through financial backing to help us publish and get it together, and presented a little passive butt kicking to help keep things moving. If you want to learn more about them, because they lend money for energy efficient projects, and they actually were very helpful to us, to me personally, as we were constructing this passive house that I'm sitting in right now. That's going to be the short presentation after I talk about the Passive Rowhouse. And you may notice some other heroes in the passive house world, suppliers that make the work possible. So what's in the manual? It's an introduction to some of the major issues that one faces when renovating a row house to a passive house. The working group thought a lot about who the manual is written for. We settled on developers, contractors, and designers, not necessarily the owner, who may not have a technical background. The owner would become an informed consumer, and that was a big part due to the good information that we wanted to put in here into the manual. It should be part of the research that the owner does when making a big investment. I'm always surprised how uninformed people who buy houses are, particularly compared to how much time they spend researching their iPhones or new cars. We tried to write the manual conversationally, but you also find that technical and building science information stimulates the inner scientist in all of us. And the following slides show one chapter per slide, but we're only going to skim the contents. I will drop the link in chat, or we'll somehow get it to you. It's a free download, of course, and I think it's got some good information for just about anybody. So why passive house? I know all of us that are on this call know why we want to do Passive House. But as we were starting this manual, we wanted to look at, said as an introduction to Passive House and to be convincing about why it's worth doing. Of course, those 5 basic principles: super insulated and airtight construction, no thermal bridges, climate and location-based design principles, high performance windows and doors, balanced and continuously filtered fresh air and exhaust through ERVs or HRVs, and right-sized and efficient mechanical systems. And so we started with chapter 1 with opportunity seeking. This is in contrast to problem seeking. We want to look for those opportunities, challenges, and risks that should be evaluated fully before construction or renovation begins, especially when seeking to achieve Passive House certification. Start with the basic row house livability, which means the building is structurally sound, sheds water, and has no hazardous materials or dangerous conditions. The Philadelphia Rowhouse Manual, and this is the cover that's on this slide, was authored by Rachel Shade, a local architect, and it's published by the City of Philadelphia. It's a great place to understand, begin understanding the row home, and it's available at the City of Philadelphia. And I think I will leave that link also. It's a great resource for owners of row homes. Chapter 2, building enclosure. You all have seen the red line that separates the unconditioned space from the conditioned space. So this chapter looks in depth at approaches to defining the enclosure. We're aiming for super insulated, airtight construction with no thermal bridges. Can be difficult to do, particularly in an existing row home. The idea, of course, is to create a thermos that keeps the inside conditions inside and the outside out. And that's where the building science begins. Chapter 3 is connections. This is where constructability meets design and existing conditions. We're looking at a common row house condition where roof structure pockets into a party wall. So how do you see air seal it? Do you need to insulate it? How do you make it thermal bridge free? All good questions. The manual has some advice on how you might do that, and definitions of, what does thermal bridge free mean? Those concepts are explained in the glossary we talk about at the end of the book. Looking at materials in chapter 4, constructing an insulated airtight building envelope focuses on air control and thermal control, aka insulation. Based on an actual project under construction, the team looked at various options, comparing cost to performance for different types of insulation, air control materials, whether they're liquid, membrane, or parging, or stucco, tapes, and sealants. And the manual also looks at some of the health aspects of Passive House construction and the materials and how they affect the indoor air quality and health of the inhabitants. Chapter 5 is windows and doors, also known as fenestration. Of course, are fundamental for Passive House certification. They have a category all their own. They're very important for air tightness, comfort, and controlling the free energy from the sun. They're also an expensive product to purchase and install. We spend a lot of time thinking about windows and doors and how to install them properly. And you can see that there are some representative details that try to hit the high spots of what you need to think about when you're actually detailing a Passive House. Chapter 6, energy. Row houses are inherently space and energy efficient. Party walls, also known as adiabatic surfaces, shading for trees and structures, and a good ratio of livable space to envelope and footprint are typical characteristics. On the other hand, row house orientation is fixed, and row houses have limited roof area for solar PV. So you just have to deal with those fixed conditions. Of course, we know that occupant use and behavior is probably the biggest effect on energy use. Heating and cooling. We strongly advocate for all electrical heating, cooling, and water heating to eliminate fossil fuel use. improve IAQ, reduce utility connections, prevent gas explosions, which does happen, connect to an increasingly clean electrical grid, and facilitate the use and incorporation of renewable energy. Green Building United, by the way, has been working in the electrification space for a while. And so on their website, which is www.greenbuildingunited.org, you can see what they've been doing in that initiative. And Rocky Mountain Institute is also a great source for electrification. Chapter 8, ERV and DWH, energy recovery ventilators and domestic hot waters. In our climate, we do use energy recovery ventilators and not heat recovery ventilators, but that of course is related to Passive House being a climate-based design criteria. So this chapter addresses those two pieces of equipment. The ERV brings in fresh air and exhausts stale air while retaining 70 to 80% of the heating and cooling energy. And that equipment may be certified by the Passive House organizations. As we saw in chapter 6 on energy, the domestic hot water used a big piece of the row house's energy pie. And so we want to be sure that we're using a well thought out piece of equipment. Chapter 9, testing, balancing, and verification. It's a quality control process that confirms whether a project is built and operated at benchmark Passive House levels, that is working as intended and as designed. Even perfectly designed buildings routinely miss performance goals when airtightness, thermal performance, and system commissioning are not verified, which is why a third-party rater who does the verification is an essential part of the project's QC plan during the construction phase. And of course, that's whether it's a certified project or if it's Passive House inspired. Making sure that your equipment works properly can only make things better. Certification includes pre-certification design reviews, energy model review, construction testing and verification, and the big yardstick, which is that whole building air infiltration test, also known as the blow-a-door test. And the blow-a-door test measures the air tightness of the building. Certifying bodies are Passive House Institute and Passive House Institute of the US. So you did it, you got to walk through the manual, got a flavor of what it takes to renovate a row house to Passive House, and we're not done yet. As one of the appendixes, we have site opportunities and constraints, and we added this appendix to help the owner and design team consider other factors such as building location, site constraints, aesthetics, and the budget while planning for a Passive House renovation. There's a checklist that helps organize the critical information and keeps the big picture in mind during the design and the construction process. And we also look at things like zoning and orientation, the condition of the existing building. You know, if you just put on a new roof, you're probably not going to want to tear off a new roof. So you need to sort of incorporate those conditions into the master plan for how you achieve the energy performance in the Passive House design. And I mentioned the glossary, which has lots of definitions. That's actually a few pages. There's a lot of jargon in the design and construction world. And we've used some unfamiliar terms and acronyms for non-professionals in this presentation. And so the glossary talks about those terms and gives some context to the building science that we're focusing on as we design the Passive Houses. And that's the end of the Passive Rowhouse Manual. However, I'm going to channel Oprah for just a second. If you look under your seat, you will find a free copy of the manual. And if it's not there, you can find the manual on the Green Building United website, which is right there. www.greenbuildingunited.org/newsroom/it's here, the Passive Rowhouse Manual. So that's the Passive Rowhouse Manual, I can, I don't know if there's any questions now, but I do have a cha-cha. I just learned that that's the proper way to say it. The cha-cha, aka Pechakucha, which is a 6-minute and 40-second presentation on the historic row home that my partner Laura Blau and I renovated to, or working on the certification to interfit. So let me stop my share for just a second. And while I'm doing that, are there any questions about the Rowhouse Manual? Is there anything in the chat?
We've had some chatter going on.
Okay.
I don't see any direct questions yet. I have a few that came to mind, but if you do, I guess as a reminder, if anybody wants to drop something in the chat so we can make sure we get to your questions, that'd be great. So I know in Philly, like Chicago, we've got older homes that are get the eye of the historic preservation community. Were they engaged in the development of the Rowhouse Manual? Are there people on the group that have that specialization and expertise? Did you address that specifically within the Rowhouse Manual?
We noted that there are situations where you may have a historic row home, and that might be that along with zoning considerations, other neighborhood and aesthetics that may put other sort of constraints, or you'd argue opportunities to maintaining a historic facade. We did not rely on, we didn't address any sort of outside, like we didn't talk to the city about the Rowhouse Manual. We did have a fair amount of internal expertise, but we do, I mentioned in the appendix, there's that sort of checklist of evaluating the existing home and trying to figure out what are some of the issues that you need to address when making a renovation and how to accommodate them. And some of those questions about, is it a historic row home, is certainly an important thing. I'm about to present our historic row home, which that was a major part of the story, it being historically, it's in a historic district. And so there's a lot of people who are looking at what we were proposing to do in our renovation. Fortunately, it was in Philadelphia, the historic district only applies to the exteriors, but unfortunately, it applies to any buildings that are, or any facades that are visible from the public way, regardless of what sort of public way you're are looking at it from. But I'll talk about that in just a second when I talk about our renovations here.
And we did get a question from Pam Hutter. If you want to come off mute and ask your question, you're welcome to.
Okay. How much, excuse me, how much credit do you give the party wall relative to insulation? Because I know that the main function of the party wall in a row house is to leach energy up and out through the top. So are you suggesting that we insulate the party wall just like it was an exterior wall? Or is there a credit there for not? Because I've also seen situations where somebody had a row house and they thought they were going to have heated neighbors on both sides, and then they didn't have a heated neighbor on one side, and they were unprepared for that. Not saying I told them so, but I told them so. But how do you address that? What's policy in your row house manual?
Yeah, that's a good question. That shared party wall is maybe the primary characteristic of row homes. We we treat it, and your energy model is probably going to treat it as an adiabatic surface, which means that there'll be no heat transfer between your property and your neighbor's property, which makes the assumption that your neighbor is heating and cooling their house at the same or very near the same temperature that you are. That's it. The issue of row homes that are next to neighbors that are not heating or cooling or are being demolished or some other change, that's certainly a problem and an issue that you need to think about when you're renovating your row home. But it's also a big social problem. It's a generational housing issue.
Yeah.
It's a structural problem, right? If you're in a row home and your neighbor's floors have rotted out, your party wall is not made to be exposed to weather, for one thing. It's not made to stand on its own without support from the floors that are adjacent to it. And so we're generally assuming that the party wall, unless the facts on the ground are different, and we're generally assuming that your neighbors are living in your house and it's conditioned space. If that's not the situation, or if you're expecting that it's not going to be the case in the future, then you need to address the issue of, do you insulate it? One thing you always do is to air seal it. While you may or may not insulate between the two, you do want to air seal it. And if your party wall is an 8-inch or 12-inch brick wall, sounds don't generally travel through that. Although one of the interesting things, and at least from a technical and an air sealing point, is if you have your floor joists, which are in joist pockets into that party wall, sometimes those joist pockets, it's the same hole that your neighbor's joists are in. Sometimes they're offset a little bit, but that's definitely a weak spot. That's difficult to air seal, or at least tedious to air seal. And it's a kind of weak spot in the wall where you might have get a little bit too much information on what your neighbor's doing next to you. But that's a great question, Pam, is, if you're a belt and suspenders and a belts kind of person, you might insulate that wall, but it costs money. And so that's sort of a balance that the row home, advantages of that shared wall can become a big disadvantage. And figuring out what do you do about that is a good question if it's a sort of a questionable situation. In our house here, our neighbors will always be occupied. Now, it doesn't mean that there might be times when if you had a neighbor that left on vacation, right, their temperature, they might turn their heat down in the wintertime, and we don't have insulation between our party walls. And so we might be heating up their space. I know that in the past, before we lived in a passive house, energy is all going back all through the walls, whether depending on what the temperatures are and the sort of situation. So I sort of look at that's part of being in your neighborhood and community. And but again, from building science, you need to make some assumptions and probably need to accommodate the worst case.
Good. You're gonna queue up the Pachacacha?
Yeah.
Come back to more questions too.
Sure. Let's get to presentation screen. Okay. Did everyone see? Yeah, there it is. 21st century Philadelphia row home. Okay, I'm gonna, although I have 20 seconds worth of text for each of the slides, I'm gonna try to keep it to that. So this is a story about a major renovation to a common Philadelphia row home. We know that row home renovations are done every day. We see construction on every block in our city, probably the same in Chicago. But design and construction, as usual, just isn't good enough anymore. And why is that? It's because we have a new gravity that we need to acknowledge. And that's the climate crisis. If you live in one of the 300,000 row homes in Philadelphia, what do you do if you want to bring your home, your building into the 21st century? There's a lot of wisdom out there, but those conventional weatherization approaches aren't good enough. We need to apply radical conservation with building science, start new habits as we update and modernize our city of homes. The project is just south of Rittenhouse Square, a nice neighborhood in center city Philadelphia. It's also located in the Rittenhouse-Fittler Historical District. The fact that it's historically registered building is an important part of the story. It has influenced the decisions we've made through the years and guide our overall goals for the Passive House renovation. When this house was built around 1845, there was no electricity from the 1890s, natural gas common in the 1920s, central heat from the 1850s, air conditioning, which Willis Carrier made popular in 1902, television invented in 1927, internet 1990, and Wi-Fi, which was common in 2000. Of course, this house and all our neighbors have all those things, except our house doesn't have gas. So we have all those things with passive house efficiency. The building's a 4-unit residential row house, 4 stories plus 1 basement. I also want to point out that the first major renovation of this building was in 1922, which was 77 years after it was built in 1845. And the second renovation, which is this current one, is 96 years after that. So what it shows me is that you need to use the best available solution because those temporary ones become permanent. And you can see that there's 4 floors. Our unit is the first floor plus the basement. We have a roof deck. The lot size is 20 foot by 90 feet, and we pretty much have built, or the building is built out almost covering almost that open, the whole lot size, with that 331 square foot of open area, which is kind of an alley at the side of the building that provides space for the windows, as you can see in this photo. That's sort of looking to that 5 foot wide opening between us and our property line. And this photo, by the way, is from our second floor, which is the owner's apartment when it was renovated in the 1920s. So besides the work to achieve the passive house performance, air sealing, super insulation, and installing passive house windows, we underpinned the basement to create a bi-level apartment for ourselves. So the basement first and second floor were gut rehabs, third floor was a partial rehab, and the fourth floor was a major rehab. Now phase 1 is complete. So we'll get to the rest of the story. And so what is a passive house? The pass-fail international building performance standard with a super insulated building envelope, airtight construction with an energy recovery ventilator, triple pane windows and superior doors, efficient mechanical systems, quality construction, a good design team, and building science analysis, including an energy model. And just like every other project, we needed a building permit. We also needed special inspections for the basement underpinning and the fire escape, and historical commission approval. To achieve passive house performance and protect the building for the next 100 years, we wanted to replace all the windows with passive house quality and insulate the rear brick walls with a stucco finish. The historical commission denied our proposal based on criteria number 2, 6, and 9 from the Secretary of the Interior Standards for Historic Preservation Projects. Now, these guidelines were written in 1976. This is 50-year-old thinking that dominates an era that's in crisis. So we need to apply building science in addition to historical criteria to solve this problem. Eventually, we were granted approval for the simulated double hung windows. although with 6/6 muntins instead of the 1920s era 1/1s. With pro bono help from Michael Sklarov and David Guest of Ballard's Bar attorneys, we were able to convince the Historical Commission to reconsider our proposal in light of the Pennsylvania Environmental Bill of Rights, which was ratified in 1971. We prevailed and began work after we had that approval. As an aside, I believe there's 17 states that have Environmental Bill of Rights that all were generally came into being in the 1970s, right? That energy crisis. We're in a bigger crisis now, so why aren't the rest of the states having environmental bills of rights? A good question. So we wanted to propose a new criteria for evaluating historic renovations. Number one, rank the historic facades as significant or non-contributing. Two, altering the facade must result in a significant improvement in energy efficiency and health incomes. And three, the proposal must be backed by proven building science-based analysis. This is looking at a photograph of Elfrid's Alley, which is the oldest continuously occupied residential street, certainly in Philadelphia and maybe in the United States. Those are important bricks, right? We're not going to, would never suggest that we cover Elfrid's Alley bricks or the bricks from Independence Hall or the bricks on the face of Pine Street, you know, our front bricks. But the back bricks in that alley, not important at all. They're, besides being in poor shape, they're also ugly and covered with the detritus of a modern world. So as we began to plan out our project, we informally identified some requirements that we knew we wanted to achieve, such as getting rid of the natural gas, supporting a viable pro forma, very important, and achieving passive house performance and certification. The historical component affected our timeline and influenced our approach in a good way as to why we are doing what we are doing. And we were very, we thought about this a lot, like what are the goals of the building and how do we achieve it? So those other projects, other requirements developed and changed as we moved on with the project. Some requirements were forced on us and subsequently informed our attitudes and goals. We did learn that many organizations don't necessarily want to set precedents like we do. The Historical Commission, for example, they don't like precedent. They like things the way it is. But we think it's important to do what we can and lead by example. So I want to propose a radically conservative approach to energy consumption in buildings. We need to use less energy and conserve more. Passive House focuses on energy use in all kinds of buildings. And since row houses define the space of the city, we need to keep them around. They are key to energy conservation as well as conserving the historical value of the city. But first, some science. I mentioned that 1722 Pine was built in 1845. It was a developer building. The Pine Street facade is beautiful and sells the house. We're looking at the Waverly Street facade, you know, not so much. As a bottom dollar developer would do today, good stuff's on the front, the cheap stuff on the rear. So we got the equivalent of 19th century vinyl siding at the rear, plus all the crap from the modern life, including phone lines and telephone power lines, all that stuff that just magically appears that helps facilitate what we do. First, we looked at the water absorption of the brick. Results, the Pine Street brick is nearly impermeable, the best brick you can buy. Many of you know building scientist Joe Stiebrick, who told us the front brick is so good that with air sealing, we could put almost any amount of insulation at the interior and not have a freeze thaw problem. The rear brick, however, is very low quality and absorbs water easily. In fact, when we were doing these tube tests, we were continually pouring water in because the brick just soaked up the water like a sponge. And of course, when the water gets in the brick, sometimes it goes through the brick, sometimes it stays in the brick, and that's where those sort of freeze-thaw issues could become a real problem. So a typical modernization is to air condition and insulate at the interior, maintaining the brick facade. When we performed a hydrothermal analysis, the WIPI program predicted an unacceptable mold risk due to the composition of the wall and the absorptive nature of the brick. This is at the rear facade. In fact, we had a tenant with a mold allergy, and we found mold and degraded plaster and brick during demolition. We created an energy model, in this case, the Passive House planning package. The program calculates required insulation levels, window performance, shading, and so forth. Begins with the project location, orientation, and climate. You can also see the model acknowledges those party walls, which are adiabatic, meaning no heat transfer. And at the right, you can see, yes, we passed. And after demolition, we rebuilt the walls from the inside, starting with underpinning the basement, an airtight layer, which, depending on where we were applying it, could be membrane, trowel-on, roll-on, or lime plaster. We added insulation, generally mineral wool or cellulose, vapor open airtight smart membrane, right? That's that Intello that you can see on the upper photos, a service cavity, and then the gypboard finish. An ERV in each unit provides energy efficient filtered fresh air. And the first thing we did was to get rid of the natural gas. And see the bottom picture on the left was a whole army of natural gas boilers, those Wheel McLean boilers that are ubiquitous, they last forever. They're very inefficient, but they're hard to get rid of. We also had natural draft gas hot water heaters, one for each of the 4 units. And currently, all apartments have been rented for 2 to 2.5 years. Still working on some honeydews and finally getting settled in. So phase 1 is complete. The next big thing to do is to finish up the certification, get started on phase 2, which is to replace the rear fire escape and install the rear insulation on top of the, covering the brick at the rear. And that's the story of our Pine Street Passive House. And you can see these are photos from, various photos from, well, I can see all the photos on the top row are from our unit. And you can see it's a more modern design. With the photo, the second one from the left with the yellow wall and the 2 hearts, that's in that basement, which had the lowered floor, new insulated slab, airtight construction down there. You can see there's other photos from the kitchen. And then the bottom photos are from the upper floors, which were generally more traditional design. And then at the right is from our roof deck. We have a phenomenal view of Center City, Philadelphia. This is looking at the Drake building with that very thin high-rise, beautiful residential building. That's not far away from where we are. And we also look at the more modern high-rises of Center City. And that is the Pachakucha.
Cha, well done. Thank you. And I apologize, I didn't mention this at the outset, but to all of those that are joining us that aren't familiar with their work, please do check out Blue Path. It really is some beautiful, elegant work. So I applaud you at not only incorporating the Passive House building science component into it, but also making it beautiful at the same time.
Thank you.
So you are not only an architect and an engineer, but you are also an occupant. What are some things that you've you noticed or enjoyed have struck you differently about being in a passive house?
There's, that's a good question. It's quiet. There is no mice. This is, we're in a city, and every fall it used to be, well, I'm sure it still happens, that the mice look for a nice warm place to live during the wintertime. When they see our passive house, they don't see any place warm. They don't see any holes to go in. So we don't have mice. And we have very few any other kinds of pests, including insects, because it's hard to get inside our house. That's a big thing. It's we've owned this building for something like 27 years, and every fall we had to put together a mice package and take to our tenants. And traps, and like we don't do that anymore. That's a big bonus. I mentioned it's quiet. One of the it's quiet relative to the outside. We don't hear cars go by. We don't hear any of the outside noise. But because it's quiet, we do hear the things that are inside a little bit more. Right, when the refrigerator turns on, we hear that. The mechanical systems, the ERV, they're pretty quiet, but in a standard house, you wouldn't, it's a sort of a level of noise, the background noise that you wouldn't notice, but you do hear it in the passive house. I would say the biggest irritation is the doors and the door hardware. For some reason, well, I understand why. Having an airtight door means that you need to put some pressure on the door and push the door against weather stripping. And so you end up with some unusual for us door hardware procedure. So we have to train our tenants how to use their door, because it's not like a regular door. You got to push the door closed, make sure it latches. You need to raise the handle to engage the multi-point locking system, and then you got to turn the knob. One of the other irritations is that the keyways are welded keyways and not adjustable keyways like we generally have here in the States, which means you can't master key these passive house doors. And so we're currently trying to locate a source of adjustable European keyways so we can reduce the number of keys that we have for our house, and also make it easier for us, but also easier for our tenants, so they have fewer keys. Another one of the things that is a fact of a passive house is that you have to change filters. And so we have a program every 3 months or 4 times a year. We go into all the apartments, including our own, and we replace all the filters in the ERVs, clean the filters in the mini split heaters and coolers. We also have condensing dryers in most of the units, and so that's a little bit different also than standard dryers. Like, it takes a little bit longer. You got to clean the filters, and there's some procedures that are slightly out of the ordinary. Having said that, our tenants are really happy. They love living here. We have all of our 3 tenants have 2-year leases, and so they were willing to, at the beginning of the lease, to say, look, I'm going to stay there for a while, and I hope that we get a couple of these are lifers. I think I'm feeling good about a couple of the tenants that they might be here a long time, which is good from a landlord's standpoint. Did it cost more to construct? Yes, of course it did. There were a number of building science issues that you just don't necessarily see very often, like how do you air seal an existing building? It's tough, but we had lots of help. We had availability of good materials. All those, a few years ago, it might have been difficult to get the right kind of materials imported from Europe generally, but there's plenty of materials around that get the job done. finding contractors that know how to use them, how to install them, that understand how important air tightness is a challenge. So we ended up doing a lot of training of the contractors. We tried to be smart and write the requirements into their subcontractors, their subcontracts. And sometimes it's successful, but I would say most of the time it's not. And then of course we were building during the pandemic, and so that had its own difficulty. That's not necessarily a passive house issue, but building in this row home where there's no lay down space, there's no parking spaces, there's no loading docks. It's just a high degree of difficulty of building, especially when you are trying to build to high performance levels.
And what did you use for air sealing?
You name it, we used it. We had in the basement on existing walls, we parged with lime plaster, which is a great material that 200 years ago they figured out why you used lime plaster, because it is airtight and vapor open. Where there was no water and we had plaster walls, we used regular plaster, again vapor tight and air vapor open and airtight. We used Mento Intello, where we had cellulose blown in dense packing cellulose. We used Roxol mineral wool whenever there was any potential wet areas. We did not use spray foam insulation, but we're not foam free. We have some foam insulation under the slabs. And there were some situations where we just had to rely, had to spray and just hope that it was going to do the job for us. And then we also just used simple fiberglass bat insulation if it was sort of a definitely low risk situation where we needed to insulate, but we knew it was an easy building science situation.
Mm-hmm. Did you, the decision to underpin, was that driven by the need to get insulation under slab, or were there other mitigating circumstances?
I would say the primary, we knew we needed to have a new slab because the basement before the renovation had about a 6-foot head height, or maybe it was 6'2". And it was just a rat slab. So we had to do something down there. We knew we needed it to be occupiable space. It had to be a part of our apartment because we needed to have the room. And that was really, I would say it's really those programmatic requirements that led us to do the underpinning, and it also facilitated the passive house energy stuff that we needed to do also. And the underpinning had its own story about, take special inspections, and there's supposed to be an engineer observing it all the times that we're doing the work. And one time the engineer wasn't here and the L&I inspector came and shut down the job. Then they lost the drawings and we couldn't find our drawings. We had to get, those are things that happen in construction. But it was something we really needed to do. And so that was just the cost of doing business, was getting the underpinning and getting a habitable space, which has nice head height and our rooms that are useful to us and we like being in. So it was kind of a mandatory that we do the underpinning to solve those problems.
Mm-hmm. We have another question from Pam Hutter. You're welcome to come off mute, asking about cost analysis, normal versus passive construction.
Say it's you.
Hi, yeah, this is Joe Laughlin. I'm Pam Hutter's partner. And my question is, do you have a cost analysis for what would be normal construction, so to speak, versus passive construction?
For this project, we didn't compare it. we were not going to do normal construction. There's also some sort of skewing of the cost. The standard answer is it depends, right? If you
Right.
put in a gourmet kitchen, it doesn't matter what you do for passive house because the gourmet kitchen's going to cost more than those energy performance and enhancements. But for us, it's a high rent district. We knew we were going to get good rents that were going to pay the mortgages. We did have a construction loan, so people were looking at what the construction costs were, but they were also not particularly informed about high performance building. They trusted us. That's right. I mentioned previously that the Sustainable Energy Fund had a loan, did loan us some money for some of the energy enhancements, and they get it. And so that was pretty easy money to get. But we had just a standard construction loan. We did have
Would you repeat that loan servicer who gave you money for doing passive?
It was just the Sustainable Energy Fund. I think the website is thesef.org. And we cobbled together the cost from a few different sources. But like I mentioned, it was primarily a construction loan, which is a story all on its own.
Right.
We did a project with a construction loan 20 years ago and swore I would never have another construction loan. However, here we are, still have to have the money to get the job done. But I would say that from a cost standpoint, it was expensive. Some of it was decisions that we made because we wanted to be a certain way. Some of it was those circumstances we're building in the city, and that's just what it cost. Some of it that was passive house, and we weren't going to do anything else but that. Some of it was that we were going to, because of our location and the quality of our building and the quality of the product that we're giving, we were going to get rents that would pay for it. And that also, facilitated the final financing, because we'd proven that we could do it for the money that they loaned us, and that we had an occupied building almost immediately. And I think that was due really to the quality of what we were doing from the building, the beauty of the building, the nice neighborhood that we live in, and younger people these days, they do care about this stuff. They if you say eco-smart building, they believe it and they value it. And so that, I think that was different than 20 years ago. We couldn't have, this pro forma wouldn't have worked 20 years ago, even 10 years ago, but it worked for our circumstance.
Yeah, as to the market that you attracted, could you parse out in some kind of quantitative way? It's throwing darts, but in some kind of quantitative way, what percentage of the market did you acquire because of either your history or your construction or your aesthetics versus the fact that it was passive house? Like what percentage of your market was astute enough and interested enough to look at your building because it was passive house versus other factors that would normally attract the market?
I would say it was most, if not all of them, were interested in the fact that that's a super green building, and it aligns with maybe their personal values. We as an example, we have a composting service, but we don't have room for for gardening or anything like that, although we do have container gardens. And we were just talking with our people upstairs, our tenants, and they were all interested in becoming part of our composting. And so I think that increased awareness of sustainable issues led them both, attracted them to this building, but maybe more importantly, attracted them to this area. Now, just another note, is that I say this often, and I think that's true. We couldn't afford to live in this house if we didn't own the building, because all of our tenants make more money than we do, and they're all tenants by choice, which means they could own a house if they wanted to, but they'd rather live, and thank them for this, they'd rather live in our building, because not only because it's a beautiful building, they have virtually no energy bills, which they don't particularly care about. We have nice neighbors, they're living in our house, and we like them, and they like us. And we live here, and so they get personal attention when they have an issue. Paul and Laura are downstairs, and will come and fix it.
Yeah.
So there's a lot of things like that.
Right.
Well, and the ironic thing about keeping long-term tenants, which as a landlord I know is an amazing thing, but we're also missing the opportunity to have disciples of living in a passive house. Maybe in your next lease you need to write in that they will profess the joys of living in a passive house every year to 5 people or something like that.
Well, it's funny you say that, Tony. At the end of this month, we are hosting both a sort of political fundraiser, and we're also hosting sort of an open house for our office, which we haven't done yet. But we're also hosting tours of the building, including the tenants' space. They're excited enough to let strangers walk into their space and talk about how much they like living here.
That's fantastic.
What date is that open house?
Well, if you're going to be in Philadelphia, March 31st. It's an in-person event only.
Yeah, right.
Are you going to be in Philly?
I might encourage myself to arrange that.
Awesome.
But what's interesting to me is we're in Chicago, which is a similar Midwestern, city. And, I was just in California, and, stuff like this flies all the time out there, but it's not particularly, well, there's not a lot of affinity for it here in Chicago. And so that you've done it in Philadelphia is really striking, because I'm a successful landlord. I know how to landlord. I'm real good at that. And I'd like to we're thinking about putting up some new row houses that are all passive house. I think that'd probably be easier to do than what you've done there. And we're trying to see if I'm interested in programs to help fund it, because when you got competitors right alongside you putting up market rate stuff with typical construction costs, and you're trying to do something that's more construction and then still compete, you'd certainly have to do something in an area which will support all the cost. That the marketing of your space is what I'm certainly interested in, and so yeah, if you'd invite me, I'd certainly come. So just to talk.
That'd be cool. Well, here's the sad part. We're the only one out of a city of 300,000 or more row homes. There's a small percentage are historic row homes. There's a small percentage, relatively, that are sort of in our area. But we're the only ones that I know of that have done it in Philadelphia. So we're not the only passive house in Philadelphia. There's some senior housing and apartment buildings that are slightly outside the center city area. Tim McDonald and Young Flats have done a number of projects that are passive house or are approaching passive house. But as far as historical projects, it's really sad. I look at Michael Ingway up in Brooklyn. It's like Michael, he's doing it. He's got a different clientele. He's doing single family very high end, very expensive, but just the most beautiful renovations generally that have passive house performance. And sometimes he does it for different reasons. It might be comfort, it might be noise, it might be indoor air quality. But it's usually not for performance because it's not about saving energy. It's about those other lifestyle things that that make living in the city
Yeah,
a great place to be.
that's an interesting component. But in my way of thinking, I think you need to conceive and develop something that you're going to have clients for, and it's got to be able to make money, and otherwise why do it? And not otherwise why do it, but that's a necessary component. I see that you're committed, you were going to do it. Well, you knew it was going to make money, so you could afford to entertain your commitment to passive house, but that certainly has to be there, and I think creating the clientele or attracting the clientele, however you do it, you've got to be sure that once you do this, you've got the clientele to cash flow it. So I mean, you can build anything. It's making it economically viable. That's the trick. So
did you, so you mentioned financing too. We did have a presentation recently from Isaac Elnicave, who talked about the Inflation Reduction Act and the opportunities to build passive within that.
Yeah, I didn't catch that.
We'll provide a link to it. He's a wealth of knowledge on that topic, but there are tax incentives per unit developed, which can go to offset some of those incremental costs. And I would also encourage you to, if it's something that you're wanting to gain more information on, the builder that we have presenting in May is going to provide a lot of real useful lessons learned as you're embarking on your journey here.
That's great. I appreciate that help. Okay.
I just put the link in the chat to the YouTube on the YouTube video on the Inflation Reduction Act. It wouldn't work in. Sorry, it wouldn't work in this case because it would need to. It's only for if you're changing hands. Yeah, you would need to be selling it or.
Yeah, that's right. But our situation is that we own the building, we're living in the building, and so that was both a limitation and an opportunity for the financing. So we don't have currently we don't have a commercial loan. We have a residential loan. Some cases, it's a four unit apartment building. So in some cases it's treated as commercial, in some cases it's treated as residential.
Right.
I still haven't worked that out exactly. If it's 5 units, it would be commercial. If it's 3 units, it'd be, and it's because we live for it. That's a sort of generally treated as a residential building. But we've it's
Yeah.
Well, the hardest part for me about any of these is having to cut off a really good conversation. But we are over time, and I want to be respectful of everybody. Paul, is there a good way to get in touch with you if people have follow-up questions?
Sure. You can email at info. I'll put in the chat, info@bluepath.us. You could call our office, and I'll put that in the chat too, which is 267-519-3564. And I encourage everyone to check out Green Building United, because there's just lots of great information. There's recorded presentations. There's an upcoming sustainability symposium. There's new gravities conferences that are focused on multi-family passive house projects. And I think those are all recorded and available online also.
Wealth of knowledge, yes. We applaud all the good work you guys are doing. So thank you again, Paul, Laura, for all your hard work, all your great work.
Sure.
Keep it up, and hopefully I will bump into you at the next FIASCon, if not sooner.
Yes, awesome. That's great.
Cheers, everybody. Have a good
Thank
night.
you all.